Alrighty, so let's do the rock climber problem. Bum, bum, bum. Alright, so in the rock climber problem, here's what we got. So it says that at time t equals 0, rock climber accidentally allows a baton to fall freely from a high point on the rock wall to the valley below him. So a baton is, I think it's like a thing that you stick into the rock to help you climb. But I guess you don't really need to know that to understand this problem. So there we go. Ooh, are there lines through my face in this little video? I might need to fix the settings on that. Alright, well, whatever. Okay, so, and then it says, then, after 1 second, his climbing partner, who's 10 meters higher on the wall, throws a baton downward. The positions are given on the graph below, or at the left, right? So, it looks like this is the graph for the first guy, and then the partner says he's 10 meters higher up, so that's why the starting position is an extra 10 meters higher, and notice the graph doesn't start until 1 second later. So here's the graph for the partner, is that purple one, okay? And so what we want to do is we want to figure out what's the initial velocity for this purple one, okay? So here is, I guess, how I would probably go about this. So we're given a bunch of information about the red one, right? The one that gets dropped. So the idea is, because it's being dropped, we know the starting velocity is 0. It's being dropped, so our acceleration is going to be, negative 9.8 meters per second squared. If you wanted to, it would be acceptable to make down your positive direction on this one. So if you wanted, you could make it positive 9.8. We know that the time that the red one falls for is 3 seconds. So I think we ought to be able to figure out how far it falls by using this guy. And if you do that, you get negative 44.1 meters. So that's how far the red baton falls. Okay? So now, based on that, we ought to be able to figure out what's going on with the purple one, the one that gets thrown, right? So for the one that gets thrown, oops, let's try that again, we'll do this in purple. So for the one that gets thrown, we don't know what the initial velocity is, that's what we're trying to find. We know that it's going to fall 44.1 meters, but plus another 10, right? So the displacement for that one, it's going to go down 54.1 meters. Don't forget to make it negative because it's going down. We know the acceleration is negative 9.8 meters per second squared. And we know that it's going to fall, let's see, it says they both hit the ground right here, right? I guess it doesn't ever explicitly say that, but the graph shows us that they have the same position after 3 seconds, right? And so the purple one only fell for 2 seconds because he didn't drop it until 1 second later, right? So our time here is 2 seconds, and now we're looking for VI. So I think we can use this same equation, delta x equals 1/2 AT squared plus VIT, and solve. So you get negative 54.1 equals 1/2 times negative 9.8 times 2, don't forget to square it, plus VI times 2, and solve it. And I was not smart enough to pull the answers up, but if you solve that, it does work. So let's see. So this is going to give you negative 54.1 equals negative 19.6 plus 2 VI. So I'm using my calculator and wasting your time. Whoa, try again. 54.1 minus 19.6. So over here, we're going to get negative 34.5 equals 2 VI, which means that VI is negative, divided by 2, 17.25 meters per second. All right, so that's how you do that one. The infamous rock climber problem. Bam. All right, how do I stop this thing? I'm messing with new software here.